Epigraphics, a tool for message-driven infographics authoring. This is work done at Adobe Research in collaboration with Huang from Brown University and Gromit from Adobe Research. The infographic is a powerful medium that helps condense complex data sets into visually compelling takeaways and stories that are easy to understand for viewers. For example, take this infographic on the left, showcasing the upstroke and downstroke positions of a canary's wingspan by coupling it with an animation of the bird and grounded on camera feed data. Now, how might one craft this infographic in a traditional workflow? Well, the standard way is to create each component separately. For example, making the graphs on D3, Matplotlib, or any plotting software. Or perhaps searching the web for appropriate images that make sense in the context of the data, or even drawing them. Then finally, composing them all on design canvases like Adobe Illustrator, Express, or Figma. However, what if we want to do more with the assets? What if we want to add animation to the visualizations, or sync them based on everything else on the canvas? Or maybe we want the colors of all the assets to be harmonious. Perhaps we even want to continue adding more assets. Doing all of this from scratch is not an easy task, especially in the context of an infographic, which requires the designer to combine everything into a clear, unified message. So in this process, there can be a lot of iteration as the designer constantly refines their content with respect to this message. From here, we make the observation that all of these infographic elements can be attributed to some aspect of this key message, or an epigraph that alludes to the content to come. So what if we can take advantage of this fact in the authoring process? Thus, our proposed system treats this text-based key message as a first-class object to automate the creation of visual elements. In this system, the users begin by writing out the key message they want to convey. Then, they can use their mouse cursors to highlight certain components of their message to use as prompts. In general, shorter components like individual words lead to more succinct recommendations, while longer ones lead to more thematic ones. From these prompts, several types of assets can be generated: a visualization, data filter, static and animated images, and color palettes. These assets can be further pairwise combined in the system to create more advanced assets that align with the message in multiple dimensions. For example, the visualization can be recolored to match the color palette of the canary, annotated to highlight a subsection of the data, or animated and synced to the flapping wings of the bird. And finally, once the assets themselves are finalized, the designer can make layout and design adjustments on the canvas. So that was a brief overview, and now I'll be going a bit more into depth about how each asset is generated. For visualizations, we pass the selected user input with the schema containing meta information of the dataset into GPU 3.5 and ask it to return relevant columns related to the message. These columns are used to produce multiple chart variations, constrained on the chart type of each column. For data filters, we instead ask for an SQL query on the data table based on the user input, then filter the data based on that query. The subsetted data is returned as a table for the user to inspect and select from. For graphics, we pre-label a database with captions using a visual question-answering model, then use sentence transformers to obtain embeddings for both the user input and the image captions. The embeddings are compared via cosine similarity, and we rank their similarities to obtain the most relevant images to the text. Animated graphics like GIFs are processed similarly using the first frame of the GIF. And finally, for color palettes, we send the user input to a text-to-image model. From each image, we then extract colors by computing 5-bin color histograms, where each of the histograms becomes a color palette option for the user. Now that all the assets are generated, they can be further refined or combined. The recommended visualizations can be animated by cycling through the values of any user-selected column. Color palettes can be combined with visualizations or images to recolor them. This is done by similarly extracting color histograms from the graphs and images, then mapping the color from the palette to them in a way that minimizes the Earth mover distance. Images can also be combined with visualizations, creating what we call data-oriented drawings, by serving as proxies to individual or aggregate data points, achieved by modifying the Bagel-like specification. Data filters can be used by itself to make graphs or be used to add overlay annotations to graphs. And lastly, animated visualizations and images can be synced to achieve greater visual cohesion. We note that these combined assets can also feed into other interactions. For example, data-oriented drawings can be further recolored or animated. So here's a demo of the system in action. The user asks for a graph, then a static as well as animated images, and finally a data filter. They then look through the options and add the assets they want to the page, making adjustments to the graph as they see fit. They can also animate the graph, recolor it based on the palette of the canary, sync the animation of the graph with the image, and make final design adjustments at the end. Here's a gallery of the infographics that we have created using this system. The top ones are recreations of existing infographics from online news articles, posters, and blogs, while the bottom ones are original infographics created using either public or open source datasets. Next, we ran a user study to understand how such a text-based workflow may influence designers by examining the intermediate and final visual artifacts created by a user and their overall interaction patterns and think-alouds during the process. We had a total of 10 participants, with varying degrees of design and programming expertise. They mostly cited experience working with design tools like Figma, Adobe Express, and Canva. During the study, they were first provided a brief explanation of the system over 10 minutes, one of two potential datasets, either one about weather conditions or about Spotify's popular songs, and a message to make the infographic with. From this, they were instructed to sketch out how they envisioned that infographic to look like for 10 minutes. Then they had 25 minutes to create the actual infographic using the system, followed by a post-survey and interview afterwards for 25 minutes. Here are some results from the study. Message-wise, there were a couple of patterns that stood out regarding which message fragments participants used for each asset type. Some examples include longer, more thematic phrases for visualizations and shorter ones for graphics and color palettes. Across the participants for the two datasets, there were also some common motifs and assets used. For example, the sun in the first dataset and the Spotify logo in the second one. Overall, from both the think-alouds and post-authoring interviews, we also found that sourcing everything from text can help standardize visual content and user mental models. Specifically, the text can help find what dataset parts are most relevant, leading to similar outcomes for graphs and data filters, as well as suggest potential physical representations of message intent for images and colors. But we note that this did not narrow thinking, but rather encouraged users to focus more on the big picture. Specifically, one participant commented that they felt more focused on design, things like composition and symbolism in the visuals. They were able to avoid tunnel visioning on the specific assets and focus more on the holistic design instead. Lastly, regardless of the type of mental models users had, ask generation from text facilitated rapid iteration. Overall, we saw that our users fell into two major personas: the confident user, who is usually more experienced and has a clear idea of what kind of assets they want. In this case, the tool helped them more rapidly go through prototypes where they could refine or even reconsider their initial visions. On the other hand, for the exploratory user who is less experienced and used the asset generation more for brainstorming and understanding what final components they want, the tool gave them a wide variety of potential candidates for what they want to convey. In summary, our contributions include a system that generates infographic assets based on a key message through user interactions with text and supports within as well as between component interactions. We also summarized a couple of extrapolated design lessons about how the message source workflow can influence design processes and outcomes. This project was also presented at Adobe Summit Sneaks as Project Infographic. Look it up to learn more.